Alright students, on to question 17. I seemingly did not press the record button and did the question, so I'm not going to go through it again. I'm just going to tell you how I did the first part. So it said calculate the mean, median, mode and range. So the mean is just the average, so we get the sum of all the values, we add all the values up and we divide by how many there are. So I got 301 as my sum, and there were 15 numbers, and so I got my average as 20.07. Before doing anything, I arranged my data in ascending order because I knew I had to calculate the median, and for the median I need that data arranged in ascending order. And so for the median, which is the middle number, I could just cross off in my green lines and find where the middle is, which was 19. But if I had a really large data set, it'd be really tough and very time consuming to find that middle number. So mathematically, if we get the number of terms n, which is 15, we add 1 to it, which is 16, and divide that by 2 or halve it, we find the term that the middle number is located in. So 16 divided by 2 is 8. So I know out of 15 numbers, the 8th number is my middle one. So then I can look at my values that are arranged in ascending order, find the 8th term, which is 19. So my median is 19. The mode is the most occurring score. In this case, I have 4 numbers that repeat themselves twice, and so I have to have all of those 4 numbers as my mode. And the range is the largest value minus the smallest value, and I got that as 32 minus 9, which is 23. Okay. Now we'll move on to part A, where it asks us to calculate the 5-number summary of the data. The minute you see this 5-number summary, know that they're going to ask you to plot a box plot, or it'll be something to do with a box plot. Okay, so I'm going to do it over here. So I've got the same values, and for part A, it's asking us to get a 5-number summary. So part A, 5-number summary using the data. So what is a 5-number summary? Here you want to get the lowest number, you want to get the lower quartile, also known as Q1. We want to get the median, we already have that, and that's sometimes called Q2. We want the upper quartile, sometimes called Q3, and we want the highest. I should use the same terminology I used here. The range, I said that's the largest, so I'll just call this one the largest. And sorry, the smallest number. And this should be the. Okay. So let's try to figure that out. So my smallest number is obviously 9. My largest number, 32. My median established is 19. So really all I need is Q1, Q3, if I know that my median is 19, I've got to find the middle of the lower side to find my lower quartile, and the middle of my upper side here to find my upper quartile. So again, I can just cross them off or use that formula, which was the number of values plus 1 divided by 2 to find the term. But these numbers are so few that I could just cross them off. So I'll cross those off, each extreme, and I find my lower quartile, 15. Similarly, on the other side, that is my upper quartile. So 15 as my lower quartile and 24 as my upper quartile. That's my 5-number summary. So then part B says calculate the IQR, which is the interquartile range. First, I want to have you visualize this. Even though if it doesn't say plot a box plot, we're going to put it into a box plot anyway. And to do that, we always start with a number line that has the range of values that we are dealing with. So our smallest number is 9 and our largest is 32. So I will go from 0 probably till about 35, and I'll go up in 5s. So I'll start at 0, 5, 10, 15, 20, 25, 30. So I use my 5-number summary as my box for my box and whisker plot. So my smallest number is 9, which is around here. I'll just put a little dot there. My lower quartile is 15, so I'll put a line where 15 is. My median is 19, put a line there. And then my upper quartile is 24, so I can put a line there. And my highest is 32. Those, you've got the box and whisker plot, and that's your lowest, the smallest. Got your lower quartile, median, upper quartile, and your highest and largest. Okay. So the question's saying for part B. So part B says calculate time we're using the quartiles. So we'll take the quartile range is the upper quartile, we'll take the lower quartile, which is 24, we'll take 15, which is 9. That's my answer for that. Part C wants us to calculate the upper and lower fences. And we use these upper and lower fences to find any outliers, which is what part B is telling us, to identify whether there were outliers. So what does this upper and lower fence really mean? So to calculate these upper and lower fences, we've got a formula. So any number that lies 1.5 times the interquartile range below the smallest value is going to be an outlier. So the lower quartile minus 1.5 times the interquartile range. If there are any numbers smaller than that, will be those numbers will be an outlier. So this is our lower fence. And for the upper fence, we're going to take the upper quartile and add 1/2 times the interquartile range. If there are any numbers larger than the upper fence, they will be an outlier. If there are any numbers smaller than the lower fence, those numbers will also be an outlier. So these formulas are in the formula sheet. I'll show you what it looks like in a second. This one is our upper fence. So if you don't memorize these formulas, that's fine. Look at the formula sheet, and it's over there under identifying outliers. Let's get back to the question. So here we've got the interquartile range, which was 9, and we already have the lower quartile and upper quartile. So for the lower fence, we've got the lower quartile minus 1.5 times the interquartile range, and our lower quartile is 15. Take 1.5 times the interquartile range, which is 9, and I get my lower fence as 1.5. So my lower fence is around here at 1.5, and I don't have any numbers that are smaller than that, so there are no outliers on that very low end. We'll do something similar for the upper fence. This time we'll add the upper quartile to 1.5 times the interquartile range. So I have got my upper quartile as 24 plus 1.5 times interquartile range, and I get 37.5 as my upper fence. So 37.5 somewhere there. And so I have no values in my box plot or in my data set itself that are smaller than 1.5. My smallest number is 9. So there are no outliers, and on the upper fence, my largest number is 32, and so because there are no values in my data set that are larger than 37.5, there are no outliers present. So part B says determine whether there are identify the outliers, if any. So we will just say no outliers. So because there are no values, lower than 1.5, I'll put in brackets the lower fence.